This is a lab problem from section 3.9. We have a boat. The boat is pulled into the dock by rope attached at the bow of the boat, passing through a pulley on the dock that is 1 meter higher than the bow. If the rope is pulled at a rate of 1 meter per second, so this is getting pulled 1 meter per second, how fast is the boat approaching the dock when it is 6 meters from the dock? So what we have to imagine is a straight line from the bow to the dock. So that would be represented by this x. The rope is represented by the value y, and then the 1 meter high compared to the bow of the ship, the boat. So here, using the diagram below, find a relationship between x and y. So it looks like we can use Pythagorean's theorem, and that is the hypotenuse squared is going to equal to the side squared and plus the other side squared. So this is how we can begin this problem. Now we have a relationship between x and y. We can take the derivative. The derivative of y squared with respect to t. The derivative of y squared with respect to t is going to be 2y times the derivative of y with respect to t, which is dy dt. And this is going to equal to 2x times the derivative of x with respect to t. And then the derivative of a constant 1 is just going to be 0. So this is the derivative of the whole equation with respect to t. Now we substitute dy dt, giving us the following. So dy dt is the rate of change of y, and the y is the rope. And the rope is being pulled at 1 meter per second. Now I'd like to just put 1 in here, but we also have to note that the y is going to get shorter by 1 meter per second. So this should be a negative y, or negative 1. And so if we solve for dx dt, we can bring this 2 over to the other side by dividing by 2x. The 2's would cancel, and then we're just going to get a negative y divided by x. So it looks like if we can find the values for x and y, then we're good. How are we going to find the value for x and y? Well, what we need to do is we need to look back at this equation. Let's actually type the equation up to make sure that we got everything that we need. That's y squared is equal to x squared plus 1. And now what we want to do is how fast is the boat approaching the dock when it is 6 meters from the dock. So the distance from the dock is this x value. So I think what we want to do is we want to get this equation, and we want to put x in for x. So I'm sorry, we want to put 6 in for x. And then when we put 6 in for x, we're going to get the value for y. And so y is going to be 36 plus 1 is 37. Therefore, y should be the square root of 37. Positive and negative, but of course you're going to consider the positive. So here are our x and y values. Now they want us to put our answer into 2 decimal places. 6 divided by, or the square root of 37 divided by 6 will not give us the value in 6 decimal places, so we need to take out our calculator and do that division. That's 37 with a square root, and then we're going to divide by 6. That's y divided by x. And this is 1.013, round off to 3 decimal places. That's just going to be And I believe this is negative because we have a negative sign. It's getting closer. So the boat is approaching the dock at 1.01 meters per second. Our answer was negative, but when you look at the picture and it's approaching the dock, we want to consider the positive speed. And so that is going to be positive 1.01. Okay, hope that helps.